Knowledge representation method for object recognition in nonlinear radar systems by Maksym Makaruk, Alexei Nazarov, Igor Shubin, and Nadezhda Shanidze. The following research consists of synthesis of two algorithms. The first one is correlation filtering algorithm for nonlinear radar systems. The rapid development of methods and techniques for radar sounding of objects with electrically nonlinear properties stimulates search of ways to optimize the structures of detecting receivers of nonlinear radar devices and algorithms for optimal signal processed in them. The relevance of these problems is due to the small range of action of modern linear radars, even when the power levels of the emitted signal are increased to values in order of tens and hundreds of kilowatts when a pulse signal is emitted. Let us list the main reasons for the low level of signal-to-noise power ratio in the receiver input. A weak level of nonlinear responses from an object with nonlinear properties and frequencies of harmonics of combination components of emitted signal. Overlap of the spectrum of the emitted signal as the spectrum of nonlinear responses in the reception band of nonlinear locator. Low values of the gain of the locator antenna. Congestion of the radio frequency range with sources of radio emissions for various purposes in the frequency range optimal for use in nonlinear radar. We propose a procedure for synthesizing an optimal algorithm for detecting a nonlinear object by the method of nonlinear radar against the background of additive noise and interference caused by the influence of the above factors. As the criterion for optimality of detection, let us take the Neyman-Pearson criterion traditionally used in radar. The optimal filter receiver, the detector calculates the values of the correlation integral and compares them with the threshold to make a decision about the presence of a target. The correlation integral in the case of receiving a signal with completely known parameters is determined by next expression, where the x-component expected response signal from a nonlinear object at the frequency of the kth harmonic of the emitted signal. In the second expression, the parameter x takes the values 1 and 0. The random noise component includes unremovable intrinsic internal and external noises of the radio receiver, which have the probabilistic irregular nature. Noises over elements, atmospheric noise, and etc. The interference component is due to the contribution of the additive mixture of the regular components of the spectrum of the emitted signal with an average frequency falling into receiver's passband, as well as the influence of external unavoidable regular interface. It can be shown that the elimination of the regular interference component from the additive mixture in the process of special processing of signal and interference in the receiver leads to improvement of reception quality indicators. The block diagram of such an optimal detector, which implements the algorithm of composing the own regular interference components in the adopted implementation, is shown in the first figure. The proposed scheme for detection objects with nonlinear properties differs from the known ones by the presence of a special channel 1 for calculating the correlation integral corresponding to the equative attributive of the noise plus interference mixture of the regular component and regular of t. Subtraction of this component leads to the increase of the signal noise plus interference ratio at the output of the signal processing device. The main elements of the circuit shown in the first figure are multipliers, integrators, and subtractor at the threshold device. To the first multiplier, together with the receiver mixture Y, A reference oscillator X is supplied corresponding to the emitted signal, which is a source of occurrence of a regular component of its own interference. The second multiplier is the main receiving channel 2, together with oscillation Y, receives the reference oscillation X, which corresponds to the expected response signal from the nonlinear objects at the frequency f from k. The reference expected oscillation X is formed in the nonlinear radar transceiver by converting the signal and the emitted radiation frequency f0 at the building nonlinear element into a harmonic component expected as a response of frequency f of k. Different indication of the products multiplication of x and y gives the values of correlation integrals to the corresponding channels of the signal receiving and processing device. Mathematically, the algorithm of optimal filter in figure 2 is described as follows. The correlational integral of the output and the first integrator of the receiving device contains three components. On the right-hand side of equation 3, in the second integral, the first factor x of t and f0 true corresponds to the regular component, and the second factor corresponds to reference emitted oscillation. The correlation integral of the second main integrator is the optimal filter has the form. And the resulting correlation integral at the output of the spectrum does not contain mutually exclusive components. The resulting correlation integral calculates the difference between fourth and third expressions is a combination of signal and noise components with a plus sign, and a noise and interference component eliminated by a receiving structure with a minus sign. The signal component of the correlation integral z of t is determined by energy of useful response signal from the nonlinear element receiving in a mixture 2 and frequency f of k. Rated the value of zr of t, the higher the probability of correct detection probability cd with fixed value of the false alarm probability of false alarm. Probability of false alarm is the unambiguously related to the threshold level set for making a decision of the process of the goal. The physical interpretation of the optimal filter procedure for detecting a response signal from nonlinear elements is accordance with algorithm is as follows. The presence of absence of useful signal is a receiver additive mixture. Results the corresponding disturbance of probability distribution density of the correlation integral at the output of the second integrator of the filter circuit P of z to k and P of z to O can be shown in figure 2. In accordance with the algorithm for optimal processing of the signal-noise mixture, the features target the detection process characteristics of nonlinear radar, which will be discussed below, are considered. The false alarm probability corresponds to error limited by the indicator of PDF and the threshold. The presence of channel 1 as a processing device ensures the elimination of a regular component from the aggregate of interference and noise, which leads to the shift of PDF P from Z to 0 to the left along to the X, and value corresponds to constant component of process and regular from T. The absence of the useful signal is the adopted implementation from 5. At the output of the circuit there are only random noise components with probability density of amplitude distribution pH3 by Z of 2O. In this case, the resulting PDF based on the normal law and the probability of false alarm in accordance with the Newman-Pearson criterion is calculated by next formula, where functional f is tabular probability integral, and this division is a signal-to-noise power ratio. Based on this formula, it's possible to determine the quantitative effect of applying the process algorithm for detecting useful signal against the background noise of interference. The analysis of alternate dependencies show that decrease of the probability of the false alarm occurs with the processing algorithm 3 to 5 manifests in a region of low values with signal-to-noise ratio, and the greater the relative contribution of the excluded component, the more pronounced this parent is. Thus, the receiver structures shown in Figure 1 and relations from 3 to 5 are respectively an optimal filter and the algorithm for detecting an object with electrical and nonlinear properties. The practical implementation of the principle of signal and interference processing proposed here provides the possibility of improving the quality of detection of useful signals while eliminating the regular components of intrinsic of external interference. The consequence of these circumstances is the possibility of increasing the range of detection nonlinear radar devices while maintaining the performance indicators of the use receiver with the required limits. Second algorithm is a quasi-optimal algorithm for nonlinear ladder information processing. As we know, the power of emitted signal is limited due to the need of ensuring an acceptable level of high-frequency radiation field affected the operator. The conversion factor of the energy and the emitted signal into the energy of higher harmonics is very small. Therefore, the main disadvantage of these nonlinear radars is short range. To increase the range of nonlinear radar, multi-frequency location is used, with nonlinear elements converted into emitted signal into a signal contains combined frequencies. The signal is received at a combined frequency f1 plus fn, and the received bandwidth delta frec is selected from next condition. Its fulfillment ensures the simultaneous reception of two more response signals from the nonlinear element through the main reception channel of the super-heterogeneous receiver. The bandwidth of the receiver as follows from 2 is very wide, which reduces the noise immunity. With dual frequency sounding, the signal is combined frequency f1 plus f2, and the components f1 and f2 comes into the passband of the receiver. Means in the comparison with a single frequency locator, multi-frequency nonlinear ladder provides a reception of 3 components of the response signal. The result is an increase in range of the nonlinear radar. Reception of response signals from a nonlinear element is provided by transferring them to the intermediate frequency region in the mixer of super-heterogeneous receiver of the locator. In this case, frequency conversion is included in the arbitrary transfer of a part of the spectrum of received signals to the intermediate frequency region to ensure the required amplification of signals and their frequency selection. However, the presence of such channels of reception on the locator with the appropriate frequency conversational cycles allows you to receive more than 3 components of a response signal. Let us consider the structures most often used in practice and receivers of radio communication, radar, radio navigation, electronic warfare, electronic intelligence structures for considering detection device, measuring the parameters of signal and interference and extraction information. These mainly include spectrum analysis and measurement receivers. Each specific version of the detection device will be determined by the type of the emitted signal: dual frequency, multi-frequency, the type of frequency conversion, up-down signal multiple, the frequency of the local oscillator tuning, upper-lower, the type of conversion, linear f1 plus f2 or non-linear, and f1 plus minus f2, etc. Therefore, the purpose of definiteness, consideration, and possibility of industrial application, we have to consider a particular situation of two-frequency sound of an object by a locator with a single linear frequency conversion with a lower local oscillator gating and with a downward frequency shift. The interpretation of the principle of frequency matching of the receiver channels with their response frequencies is graphically shown in Figure 4. It shows that the nominal ultimate frequency is selected from the next condition. So if you select the frequency of tuning of the local oscillator or the locator receiver equal to the top frequency of emitted signal, then the total component of the response from the nonlinear element frequency will be received through the main relevant channel. In this case, by the managed reception channel of the receiver, the signal of the next frequency will be received as the image, which is one intermodulation frequencies of the products of nonlinear conversion of emitted signals by a target object. Here we can see figure 4, a principle of frequency matching. Thus, due to the fulfillment of conditions 12 and 9, and also when heterogeneity equals to 2f1, in the dual frequency nonlinear ladder, the reception of 7 products of nonlinear conversion by the nonlinear element of emitted signal is provided through the most sensitive reception channels, and the reception in the most powerful responses at frequencies f1 plus 2 and f2 with f1 is provided. In practice, when designing a multi-frequency nonlinear ladder, this can be achieved by increasing the sensitivity of side reception channels, including a fit and notch tone of f-if, excluding the paraselector to improve the sensitivity along the minor channel. While in the traditional superheterogeneous receiver, measures are taken to weaken upward the side channels of these measures. The first important condition to achieving the goal of the commutation of passbands is such a choice of intermediate frequency is a superheterogeneous receiver with one linear frequency conversion downward, so that the most sensitive operation channel considers with the difference with the combination frequency of radiation for the nonlinear element f2-f1. The second requirement for nonlinear ladder is the choice of the receiver local oscillator frequency equal to the value of 2f1. The next important requirement of the receiver is the process nonlinear radar system structure is to take measures to improve the sensitivity of the radar receiver over the intermediate frequency channel and other side reception channels. Thus, new distinctive features of nonlinear radar include the choice of the nominal intermediate frequency in accordance to the condition f2-1, as well as the choice of the frequency of the receiver local oscillator equal to the frequency 2f2, increasing the sensitivity of the side receiving channels in non-linear ladder. The possibility of practical implementation of process device is confirmed by the following decisions. The appropriate choice of blocker oscillator frequency is heterogeneous frequency equals to 2f1. Also contributes to an increase of the detection range due to the coincidence of the main and image reception channel with the response frequency from the object. Thus, the proposed location device, when the measures are implemented, the number of responses received through various receiving channels of nonlinear radar increases, and the most sensitive receiving channels corresponds to high amplitude frequency response from nonlinear element. The proposal structure of the nonlinear radar provides an increase of the equality indicators of the detection of nonlinear element by increasing the signal-to-noise ratio at the output of the intermediate frequency receiver's path, which is due to optimization of principles of receiving design, measurement frequency characteristics of the frequency selectivity of the receiver with the radiation spectrum of nonlinear element. We can see the main parts of the presented dual frequency detection device. With next, and the block diagram of the presented dual frequency detection is shown in figure 5. Here we can see that it consists of modulator. The first block consists of the high frequency signal at frequency f1. The second conditioner of the high frequency signal at frequency f2. Frequency multiply f1 by 2 times. Receiver with a detection device, broad band antenna, undetectable nonlinear element that we are trying to detect. As a result, the specifier of nonlinear radar measurements is considered in the technological procedure for synthesizing optimal structures and algorithms for detecting and measuring the characteristics of objects with nonlinear electric properties by identifying possible results for increasing the signal-to-noise energy ratio in the receiver output. One of the main such results of the elimination of a regular component of radio interference caused by influence of the frequency harmonics of the probe signal formed to the transmitter of the nonlinear locator. It is shown that the use of noise and noise-like signals in nonlinear radio engineering systems is combined with the methods of the information probabilistic processing makes it possible to improve the technical characteristics of the systems. The proposed set of the new technical solutions in the field of the theory of nonlinear radar measurements is presented in the form of structural diagrams and algorithms for optimal signal reception and advanced technology of radar sensing and measuring the coordinates of objects with nonlinear electric properties.